Today we are going to start with the next topic of our chapter, reflection of light, which is spherical mirrors. So reflection through spherical mirrors. Now before going to the what is spherical mirror and how does reflection happen through it, we must understand what is convergence and divergence. So we have introduced the concept of beam of light in the last video, beam of light. So there were three kinds of beams. Beam is, you can say, bunch of light rays together. The first type of beam was parallel rays of light forming a beam. Second was converging beam of light, which looked like this. And the third was diverging beam of light, which looked like this. Converging beam of light is used when we want to concentrate a light at a point. And this type of beam is used by doctors to concentrate light on teeth, ears, eyes, etc. It is also used in solar water heater and other devices. Diverging beam of light is used when we want to spread the light from a point source of light. This type of beam is used in street light, in you can say headlight of vehicles, etc. Both the beams have practical utility and therefore we need devices to produce converging and diverging beams. Plane mirror reflects a parallel beam of light. It does not produce converging or diverging beam. Plane mirror produces an image which is of the same size as that of the object, but there are a number of applications where we need bigger or smaller images as compared to the size of object. So for that we need spherical and parabolic mirrors to fulfill these applications. So what is a spherical mirror? A mirror whose reflecting surface is a part of a hollow sphere of glass is called spherical mirror. Please note down this definition. A mirror whose reflecting surface is a part of a hollow sphere of glass is called a spherical mirror. The diagram for spherical mirror is shown over here. So this dotted line you see, it's a hollow sphere, and part of this hollow sphere is this part which you see over here. I'll just show you with a highlight. Yeah, this part which you see over here is the spherical mirror. Now if you see, this surface, inner surface, is the reflecting surface. Outer surface of the sphere, part of the sphere, is silvered surface. So reflection happens through the inner surface, and that's why this is known as a concave mirror. So the reflecting surface is caved in. Reflecting surface is caved in. Caved in मतलब वो अंदर की तरफ curved है, reflecting surface. So whenever the reflecting surface is caved in, it is known as a concave mirror. But on the other hand, we have another sphere in which we are just swapping the reflecting surface and silvered surface. Now the silvered surface is the inner surface and reflecting surface is the outer surface. Here the reflecting surface is bulged out, is bulging out or bulged out. वो बाहर की तरफ bulge out हो रहा है, reflecting surface. And this kind of mirror is known as convex mirror. This type of mirror is known as convex mirror. So concave mirror and convex mirror has this one major difference. Concave mirror has the reflecting surface caved in and silvered surface bulged out, and convex mirror has the reflecting surface bulged in and silvered surface on the inner caved in surface. So here you see only 2D, you can say diagram, two-dimensional diagram of concave and convex mirror or spherical mirror. Actually, this is a sphere. I'm sure all of you know what is a sphere. Sphere is a three-dimensional, you can say three-dimensional circle, three-dimensional circular object. Let me show you a diagram where I can show you the 3D, you can say representation of spherical mirrors. So this is the exact thing which I am talking about. Now as you see over here, there is a sphere which you can understand now in a better way. It's not a circle, it's a sphere. And there are two parts of sphere which we can see. One part has outer surface as a reflecting surface, another part has an inner reflecting surface. So this is a convex mirror and this is a concave mirror. So now we can understand that each kind of mirror is part of a sphere, and that's why these two mirrors are known as spherical mirrors. Mirrors whose surfaces are part of a sphere, of a hollow sphere, and that's why this definition. Hollow sphere of glass, that means it should be reflecting, it should not be transparent. Okay, so this is how spherical mirrors look in real life. If you want to see spherical mirror in your home, you can see a spoon. A spoon has both spherical mirrors in it. The inner curved surface of the spoon is a concave mirror and the outer curved surface of the spoon is convex mirror. Okay. So here they have given the definition of concave and convex mirrors. Please note it down. A spherical mirror in which or which has reflecting surface towards the center of the sphere of which the mirror is a part is called concave mirror. Very good definition. A spherical mirror in which the reflecting surface is towards the center of sphere. Here the reflecting surface is towards the center of sphere. They are facing each other. You can imagine a hollow sphere, imaginary hollow sphere, and the reflecting surface, if it is facing the center of this imaginary hollow sphere, then it is a concave mirror. But if the reflecting surface is away from the center of the sphere of which the mirror is a part, then it is known as a convex mirror. Here the reflecting surface is facing this side and the silvered surface is facing the center of the sphere. Hence, this is known as convex mirror. So, this is the diagram which explains that sentence very clearly. If the concave side towards the it's towards the center, that means it's a concave mirror. That means reflecting surface is the concave side. If the reflecting surface is a convex side, then it must be facing away from the center. Now let's come to some definitions or some terminologies related to spherical mirrors. Now these definitions must be memorized. I will help you memorize these definitions. So as you watch this video, these definitions will be uh, easily learnt by all of you. So there are few things which you will notice they are present in this diagram. We have both the diagrams. We have concave mirror over here, concave mirror, and we have a convex mirror, concave mirror and a convex mirror. So this is the reflecting surface, and here the reflecting surface, let me show you, reflecting surface is caved in concave mirror, and here the reflecting surface is bulged out, caved in, bulged out. Some important terms related to spherical mirrors. Center of curvature. Number 1. It is the center of the sphere of which the mirror surface is a part. How do we remember this definition? Center of curvature. This is the first definition which we are learning. Now what you guys will do, you will listen to me, you will repeat the definition after me, and then you will write the definition without copying it down. Okay? Don't copy it down while I'm speaking. When I tell you to write it down, or when I complete the definition, then you can note it down. Center of curvature of a spherical mirror is the center of a sphere of which the surface of the mirror is a part. This is the definition which is made by me. What is center of curvature? Center of curvature is the center of a sphere. Okay? Center of a sphere of which the surface of the mirror is a part. ये जो मिरर है उसकी सरफेस जिस स्फीयर का पार्ट है उस स्फीयर के सेंटर को सेंटर ऑफ कर्वेचर बोलते हैं. सो दिस इज इन लेमेन्स टर्म्स. मैंने एकदम हिंदी में नॉर्मल कन्वर्सेशन लैंग्वेज में तुम्हें डेफिनेशन बना के दे दिया. So you can make these definitions and they will be accurate according to the terminology, or you can say uh, uh, logically nothing will be wrong in the definition. So you don't have to memorize, you have to understand the definitions here and then you have to write it yourself. You can frame the definitions. You have the liberty in this chapter to frame the definition. In fact, definitions can be framed if you have proper command on terminologies and keywords which are used in physics or science. So here the definition becomes: center of curvature of a spherical mirror is a center of a sphere of which the surface of the mirror is a part. Center of curvature of a spherical mirror is the center of a sphere of which the surface of the mirror is a part. ठीक है, मैंने 2-3 बार रिपीट किया. अब तुम वीडियो पॉज करके रिपीट कर सकते हो डेफिनेशन. नहीं है तो वापस जाओ, रिवाइंड करो और फिर से सुनो मैंने क्या बोला और रिपीट करो. माइंड में उसको 3-4 बार रिपीट करो. क्लासरूम में जब भी बच्चे आते थे तो मैं उसको रिपीट करवाता था. ठीक है, और इसको लर्न करवा देता था मैं. लेकिन अगर तुम्हें लर्न नहीं हो रहा है अभी, वीडियो पॉज करके लर्न कर सकते हो तुम, फिर आगे बढ़ो. ठीक है, फिर से एक बार लास्ट टाइम रिपीट कर रहा हूं. सेंटर ऑफ कर्वेचर ऑफ अ स्फेरिकल मिरर इज द सेंटर ऑफ अ स्फीयर ऑफ विच द सरफेस ऑफ द मिरर इज अ पार्ट. हो गया सेंटर ऑफ कर्वेचर. चलो, इसके बाद मैं लेता हूं रेडियस ऑफ कर्वेचर. पोल पे बाद में आते हैं. Radius of curvature of a spherical mirror is the radius of a sphere of which the surface of the mirror is a part. तो radius of curvature में मैंने सिर्फ सेंटर की जगह रेडियस डाल दिया. सेम डेफिनेशन, जहां जहां सेंटर था उसको हटा के रेडियस डाल दिया. Radius of curvature of a spherical mirror is the radius of a sphere of which the surface of the mirror is a part. तो ये हो गया radius of curvature. Then it is pole. Center of spherical mirror is called pole, or you can say geometrical center of the surface of spherical mirror is called pole. ये जो पूरी सरफेस है इसका जो ज्योमेट्रिकल सेंटर है उसको पोल बोलते हैं. दोनों में होते हैं, कॉन्वेक्स में भी होता है पोल और कॉनकेव में भी होता है. सो मजे की बात यह है कि कॉनकेव मिरर और कॉन्वेक्स मिरर ये दोनों में पोल, सेंटर ऑफ कर्वेचर और रेडियस ऑफ कर्वेचर, ये तीनों की डेफिनेशन कॉमन है. मतलब सेंटर ऑफ कर्वेचर, रेडियस ऑफ कर्वेचर और पोल की डेफिनेशन दोनों टाइप के स्फेरिकल मिरर्स, कॉनकेव और कॉन्वेक्स पे एप्लीकेबल है. ठीक है, उनके लिए अलग अलग याद करने की जरूरत नहीं है. ठीक है, पोल की डेफिनेशन क्या हो गई? पोल इज द ज्योमेट्रिकल सेंटर ऑफ द सरफेस ऑफ द स्फेरिकल मिरर. अब तुम बोलोगे सर हमारी बुक में थोड़ा सा अलग है ये डेफिनेशन, थोड़ा सा वर्ड्स यहाँ वहाँ है या कुछ वर्ड्स आपने एक्स्ट्रा बोले हैं, डज नॉट मैटर। तुम्हें अगर कंफर्टेबल है तुम वो याद करो, लेकिन मैं तुम्हें सजेस्ट करूंगा दैट यू रिमेंबर ओनली दैट डेफिनेशन विच यू कैन अंडरस्टैंड। If you can frame that definition without losing its meaning and without losing any technical keyword, then you do that. Frame the definition. I will always be in favor of framing the definition rather than ratta maroing. ठीक है, विदाउट सोचे समझे रट्टा मत मारो, डेफिनेशन फ्रेम करके लर्न करो, ज्यादा अच्छा रहेगा। ठीक है, सो पोल इज द ज्योमेट्रिकल सेंटर ऑफ द सरफेस ऑफ अ स्फेरिकल मिरर। बात खत्म। ये जो सरफेस है उसका सेंटर है पोल, ज्योमेट्रिकल सेंटर। देन प्रिंसिपल एक्सिस। प्रिंसिपल एक्सिस कहाँ है यहाँ पे? ये जो तुम्हें दिख रहा है ना एक्स एक्स डैश, या यहाँ पे भी एक्स डैश एक्स दिख रहा है तुम्हें, दैट इज द प्रिंसिपल एक्सिस। प्रिंसिपल एक्सिस इज एन इमेजिनरी लाइन। Principal axis is an imaginary line passing through center of curvature and pole of a spherical mirror. Principal axis is an imaginary line passing through pole and center of curvature of the spherical mirror. Principal axis is an imaginary line passing through pole and center of curvature of a spherical mirror. दोनों टाइप के मिरर के लिए प्रिंसिपल एक्सिस की डेफिनेशन वही रहेगी। ठीक है, यहां पे ये लोग ने इमेजिनरी लाइन वर्ड यूज नहीं किया है, तुम यूज करोगे तो कोई फर्क नहीं पड़ता है। इट इज एन इमेजिनरी लाइन, ऐसी कोई फिजिकल लाइन तो होती नहीं है। ठीक है, उसके बाद है अपर्चर। अपर्चर इज द एरिया ऑफ द मिरर विच इज अवेलेबल फॉर रिफ्लेक्टिंग लाइट। मैं इसको बोलूंगा अपर्चर इज द सरफेस ऑफ अ स्फेरिकल मिरर थ्रू विच रिफ्लेक्शन टेक्स प्लेस। अपर्चर वो सरफेस है स्फेरिकल मिरर का जिसके ऊपर रिफ्लेक्शन होता है। अपर्चर इज द एरिया ऑफ द स्फेरिकल मिरर थ्रू विच रिफ्लेक्शन हैपन्स। ठीक है, अपर्चर इज द सरफेस ऑफ अ स्फेरिकल मिरर थ्रू विच रिफ्लेक्शन हैपन्स। ओके, अपर्चर हो गया। द लीनियर अपर्चर इज एम एम डैश। यहां पे तुम्हें अगर अपर्चर देखना है तो एम एम डैश, ये लीनियर है। मैंने तुम्हें इसका 3D डायग्राम भी बताया है, यहां पे मैं तुम्हें अपर्चर बताता हूं। ये जो पूरी सिल्वर्ड सरफेस दिख रही है ना तुम्हें ग्रे कलर की, अंदर वाली और बाहर वाली, ये पूरा अपर्चर है। अपर्चर तुम्हारे मिरर की सरफेस है जिसको तुम टच कर सकते हो, जहां से रिफ्लेक्शन होता है। ठीक है, समझ में आ गया अपर्चर क्या है? चलो आगे बढ़ते हैं। अच्छा, कुछ नोट करने के लिए बोला है चीजें। द लॉज ऑफ रिफ्लेक्शन फॉर प्लेन मिरर आर एप्लीकेबल टू स्फेरिकल मिरर्स ऑल्सो। मतलब जो लॉज ऑफ रिफ्लेक्शन हमने प्लेन मिरर में पढ़े थे वो स्फेरिकल मिरर्स पे भी एप्लीकेबल है। राइट, तो तुम्हें कोई नए लॉज बनाने की जरूरत नहीं है। एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्लेक्शन यहां भी इक्वल होंगे। और दूसरा लॉ है, लॉस ऑफ रिफ्लेक्शन हमने पढ़े थे क्या? मैंने तुम्हें बताया था। दूसरा लॉ क्या था? द इंसिडेंट रे, द रिफ्लेक्टेड रे एंड द नॉर्मल एट द पॉइंट ऑफ इंसिडेंस ऑल लाई इन द सेम प्लेन। ये सेम, ये दोनों लॉज यहां भी एप्लीकेबल है। स्फेरिकल मिरर्स के लिए कोई नए लॉज नहीं है। ठीक है, अच्छा, एट एनी पॉइंट Q on the mirror, the normal is the line joining that point and the center of curvature. A ray of light passing through the center of curvature and striking the mirror has a zero angle of incidence. According to laws of reflection, the angle of reflection should be zero. This means that the ray retraces its path. इसका क्या मीनिंग है मैं बताता हूं, इसके लिए फिगर नंबर 18 देखना पड़ेगा तुम्हें। सो कोई भी रे ऑफ लाइट, any ray of light is, if it is incident on the spherical mirror through the center of curvature, it gets reflected back along the same path. It gets reflected back along the same path because this ray of light which is incident through the center of curvature is believed to be having an angle of incidence of 0 degree, is believed to be incident normally। मतलब कोई भी स्फेरिकल मिरर में सेंटर ऑफ कर्वेचर से इंसिडेंट होने वाली लाइट नॉर्मली इंसिडेंट होती है. ठीक है. इफ इट इज इंसिडेंट नॉर्मली, दैट मीन्स द एंगल ऑफ इंसिडेंस इज जीरो, सो एंगल ऑफ रिफ्लेक्शन ऑल्सो मस्ट बी जीरो. दैट मीन्स आफ्टर रिफ्लेक्शन द रे ऑफ लाइट will be reflected back along the same path. It will retrace its path. मतलब जिस पाथ से वो आई है, इंसिडेंट हुई है, उसी पाथ से वो वापस जाएगी. बट ये कब होगा? व्हेन द रे ऑफ लाइट इज इंसिडेंट थ्रू सेंटर ऑफ कर्वेचर. ऑलवेज रिमेंबर, मिरर के किसी भी सरफेस को सेंटर ऑफ कर्वेचर के साथ ज्वाइन करोगे तो तुम्हें नॉर्मल मिलेगा. उस पॉइंट के लिए वो नॉर्मल मिलेगा. ठीक है. सो ये स्फेरिकल मिरर में थोड़ा सा अलग है. इट इज लिटिल बिट डिफरेंट फ्रॉम प्लेन मिरर. And the distance mm dash between the extreme points on the periphery of mirror is called linear aperture, जिसकी बात ये लोग ने यहाँ पे की है. mm dash, ये straight dotted line दिख रही है, इसको बोलते हैं linear aperture. The angle subtended by the periphery at the center of curvature is angular aperture. Periphery जो एंगल सबटेंड करता है एट द सेंटर ऑफ कर्वेचर, ये पेरीफेरी अगर सेंटर ऑफ कर्वेचर पे जो एंगल बनाएगा उसको बोलते हैं एंगल ऑफ अपर्चर. यहां पे एंगल ऑफ अपर्चर क्या होगा? C को M से ज्वाइन करो और C को M डैश से ज्वाइन करो, तो इसको क्या बोलते हैं? एंगल ऑफ अपर्चर. एंगल ऑफ अपर्चर. एंगल ऑफ अपर्चर. ठीक है. सो दिस इज एंगल ऑफ अपर्चर. एंगुलर अपर्चर भी बोलते हैं इसको. ओके. सो दिस वाज, I think there are few more definitions which are not covered over here, but those definitions I think we will come across ahead. Yes, focus and focal length. इसके definitions हम लोग आगे पढ़ने वाले हैं और इसको आगे थोड़ा डिटेल में भी पढ़ेंगे. इससे पहले we'll look at some sign conventions for spherical mirrors. Sign conventions, please note कर लो इसको. For spherical mirrors, for understanding and remembering sign conventions you have to make this figure. ठीक है. Number 1, measurement along principal axis. तो what are the sign conventions for measurement along principal axis? The measurement along principal axis always starts from P. P दिख रहा है तुम्हें यहाँ पे? P is the pole. Always measure the distances along the principal axis from pole, starting from pole. From P, if you measure a distance in the direction of incident ray, the measurement is taken as positive. Distances towards incident light are taken as positive. P से right में सारे distance को positive consider करो. P से left में सारे distances को negative consider करो. Now this is just like your number line. नंबर लाइन पे क्या होता है? यहां पे 0 होता है. 0 से राइट में और 0 से लेफ्ट में, वी नो द साइन कन्वेंशन. 0 से राइट में सारे पॉजिटिव नंबर्स आते हैं, 0 से लेफ्ट में सारे नेगेटिव नंबर्स आते हैं. जस्ट लाइक योर नंबर लाइन, जस्ट लाइक योर एक्स एक्सिस ऑन कार्टेशियन प्लेन. तो ये जो पोल है, इट इज कंसिडर्ड टू बी योर ओरिजिन. तो पोल से राइट में सारे डिस्टेंस पॉजिटिव मेजर करेंगे हम, पोल से लेफ्ट में सारे डिस्टेंस नेगेटिव मेजर करेंगे, लेकिन डिस्टेंसेस विल बी ऑलवेज मेजर्ड फ्रॉम पोल. ठीक है. दैट इज फर्स्ट साइन कन्वेंशन. ये दोनों हमने कवर कर लिया. सेकेंड साइन कन्वेंशन इज मेजरमेंट्स परपेंडिकुलर टू द प्रिंसिपल एक्सिस. दैट मीन्स अलोंग वर्टिकल एक्सिस और वाई एक्सिस. जो भी डिस्टेंसेस है हम पोल से ही मेजर करेंगे. पोल से या फिर प्रिंसिपल एक्सिस से ऊपर की तरफ जो मेजरमेंट होंगे वो पॉजिटिव होंगे और नीचे की तरफ जो मेजरमेंट्स होंगे वो नेगेटिव होंगे. The height measured upwards of the principal axis is taken as positive and the height measured downwards of the principal axis is taken as negative. ठीक है. So these are the measurements perpendicular to the principal axis. Okay, so these are the sign conventions for spherical mirrors. Please remember, just like your Cartesian plane, the sign conventions are there, but the measurements has to be taken from pole. Your origin must be pole. Now coming to the focus and focal length of spherical mirrors. Focus and focal length of a concave mirror. So when a beam of parallel rays of light strikes a concave mirror, remember the parallel rays of light must be parallel to the principal axis. So when the rays of light parallel to the principal axis strikes a concave mirror, after reflection they converge and meet at a point, and this point is known as focus. Focus, principal focus, focal point, these are all one and the same thing. So focus or principal focus or focal point, one and the same thing. Okay, that is this point we are talking about. So the definition of focus for a concave mirror, concave spherical mirror, is focal point is a point on the principal axis such that when the rays of light incident parallel to the principal axis strikes a concave mirror, after reflection they converge and meet at this point. Or you can say that a beam of light parallel to the principal axis after reflection from a concave mirror converges to a point on the principal axis. This point is known as focus or principal focus or focal point. So there can be many ways in which you can make this definition. You just have to remember the story. हो क्या रहा है? The rays of light are incident parallel to the principal axis. They strike the concave mirror, they converge, and they meet at a point on the principal axis, which is known as the focus of concave mirror. Okay, so you can frame this definition in whichever way you like, but you do not miss out on any single fact which is happening. Rays of light incident parallel to the principal axis on a concave mirror converge and meet at a point after reflection. This point is known as principal focus or focal point of a concave mirror. Now there are few things which are to be remembered regarding focus, that the distance between focus and pole is known as focal length. So that's one more definition, focal length. You see this F, this is the distance between focus and pole. Focus of a concave mirror is real. That means the rays of light are actually meeting at this point. That's why it is real. Focus is a point where focal length is a distance. Focus is a point and focal length is a distance. Concave mirror is called converging mirror because it converges the parallel beam of light falling on it and it makes them meet at a point, which is focus. Focal length of concave mirror is always negative, always negative. For concave mirror, the focal length is measured to the left of the pole, and we know that left of the pole is the area of, or is the distance which is measured in negative. So focal length of concave mirror is always negative. So these are few facts regarding the focal length of a concave mirror. Okay, let's skip this activity, not much important. Let's go to this focus and focal length of a convex mirror. Now remember what is happening over here. When the rays of light are incident parallel to the principal axis on a convex mirror, they diverge and appear to be coming from a point behind the mirror, which is known as focus of a convex mirror. क्या हो रहा है? Rays of light are incident parallel to the principal axis. और क्या हो रहा है? After reflection, they are diverging. और क्या हो रहा है? They are appearing to be coming from a point behind the mirror. ऐसा लग रहा है कि ये जो rays of light है, they are emerging from a point behind the mirror. So the rays of light are not actually meeting at this point, but ऐसा लग रहा है कि वो यहीं से निकल रहा है. So they are appearing to be emerging from this point behind the mirror, which is known as principal focus or focal point of convex mirror. So when the rays of light are incident parallel to the principal axis of a convex mirror, after reflection they diverge and appear to be coming from a point behind the mirror, which is known as focus of a convex mirror. And the distance between pole and focus is known as focal length here also. ठीक है, सो इसका डेफिनेशन तुम पूरा जो सीरीज ऑफ इवेंट्स है जिस तरीके से हो रहा है, पहले रेज ऑफ लाइट इंसिडेंट हो रही है पैरेलल टू द प्रिंसिपल एक्सिस, फिर वो कॉन्वेक्स मिरर को स्ट्राइक कर रही है, फिर रिफ्लेक्ट कर रही है, ये सारे चीज़ों को ध्यान में रखते हुए यू कैन मेक अ प्रॉपर डेफिनेशन ऑफ फोकस ऑफ अ कॉन्वेक्स मिरर. अब कुछ चीज़ें जो तुम्हें याद रखनी है. फोकस ऑफ अ कॉन्वेक्स मिरर इज वर्चुअल बिकॉज द रेज ऑफ लाइट आर नॉट एक्चुअली मीटिंग एट दिस पॉइंट, दे आर अपीयर टू बी कमिंग फ्रॉम दिस पॉइंट. That's why it is virtual. Convex mirror is called a diverging mirror. Why? Because it diverges a parallel beam of light incident on it. And focal length of convex mirror is always positive. Why? Because it is on the right side of the pole. It is measured to the right of the pole. Relation between radius of curvature and focal length. Consider figure number 23. Consider in figure number 23 a ray AB parallel to the principal axis falling on a concave mirror at B. A ray parallel to the principal axis falling on a concave mirror at B. देखो अभी हम क्या कर रहे हैं पता है, वी आर फाइंडिंग अ रिलेशनशिप बिटवीन रेडियस ऑफ कर्वेचर एंड फोकल लेंथ. कैसे करना है, इसलिए ये डायग्राम समझना जरूरी है. सो वी कंसिडर अ रे ऑफ लाइट ए बी विच इज पैरेलल टू द प्रिंसिपल एक्सिस. आफ्टर रिफ्लेक्शन ये रे ऑफ लाइट कहां से जाएगी, इट विल पास थ्रू फोकस. ठीक है, दिस रे ऑफ लाइट, विच एवर रे ऑफ लाइट इज इंसिडेंट पैरेलल टू द प्रिंसिपल एक्सिस, आफ्टर रिफ्लेक्शन इट पासिस थ्रू फोकस. द डॉटेड लाइन सी बी इज द नॉर्मल. ठीक है, ये नॉर्मल होगा. कोई भी पॉइंट को मिरर पे अगर सेंटर ऑफ कर्वेचर से ज्वाइन करेंगे तो वो नॉर्मल की तरह एक्ट करता है, ये मैंने पहले ही बताया था तुम्हें. तो यहां पे ये होगा एंगल ऑफ इंसिडेंस और ये होगा एंगल ऑफ रिफ्लेक्शन. नाउ सिंस this line, that is principal axis, and the incident ray are parallel to each other, this angle of incidence will be equal to this angle of reflection, means this angle over here. That means ये भी I है और ये भी I है, मतलब ये तो R है, R और I इक्वल है, और ये I इक्वल है. इसका मतलब दिस एंगल इज इक्वल टू दिस एंगल. इसका मतलब है दिस लेंथ FC इज इक्वल टू FB. FC is equal to FB. Now, अगर FC is equal to FB तक तुम्हें समझ में आया तो मैं आगे बता देता हूं. बहुत इजी है. कोई भी स्मॉल स्फेरिकल मिरर होता है, उसका अपर्चर बहुत छोटा होता है. तो ये जो FB और FP है वो उनकी लेंथ भी सेम होगी. सिंस नॉर्मल spherical mirror has a small aperture, hence we can say that FB is equal to FP. FB is equal to FP. इसका क्या मतलब हो गया कि CF will be equal to FP. CF will be equal to FP and CF plus FP is equal to CP. ठीक है, सो हम बोल सकते हैं कि 2 times FP, क्योंकि CF और FP तो इक्वल है ना, 2 times FP is equal to CP. So we can say that FP is equal to half of CP. Now what is FP? FP is the focal length, small f. And what is CP? CP is the radius of curvature, which is R. So focal length is half the radius of curvature, or radius of curvature is double the focal length. So this is the relationship between radius of curvature and focal length. ठीक है, समझ में आया? बहुत easy है. यहाँ पे लिखा है, if the aperture of concave mirror is small, then the ray of light AB will be very close to the principal axis and point B will be very close to point P. So FB will be approximately equal to FP. और फिर जैसे मैंने सॉल्व किया था वैसे ही वो लोग ने ये रिलेशनशिप निकाला है. फोकल लेंथ इज हाफ द रेडियस ऑफ कर्वेचर. Okay, now there are the next topic is ray diagrams or rules for drawing ray diagrams for a concave mirrors. Okay, so we are going to cover ray diagrams in the next video. I don't want to stuff everything, all the information in one video. So after completing the next video, I'm going to give you the homework. Okay, so let me finish spherical mirrors, at least the ray diagram part, in the next video. Then comes the numericals part, that also I have to cover. Let's see how many videos I can make. But I think that it was a very good introduction to spherical mirrors today, and all of you guys should have proper notes and everything ready for spherical mirrors. Okay, so see you in the next video. Bye bye.